स्टडी विथ मी ब्लॉग्स में आप सभी का स्वागत है। तो आज हम पढ़ेंगे फंक्शनल बुक पढ़ेंगे, गाइटन एंड हॉल टेक्स्ट बुक ऑफ मेडिकल फिजियोलॉजी, चैप्टर नंबर 1 पढ़ेंगे। वैसे इसको तो मैं कई बार पढ़ चुका हूँ, लेकिन जितनी बार पढ़ता हूँ कुछ नया चीज़ सीखने को मिलता है, तो पढ़ते हैं। ठीक है, इस चैप्टर के साथ अपना एक ट्यूनिंग बनाना चाहिए। सो चैप्टर नंबर 1 हो गया फंक्शनल ऑर्गेनाइजेशन ऑफ द ह्यूमन बॉडी एंड कंट्रोल ऑफ इंटरनल एनवायरनमेंट। बुक का नाम है गाइटन एंड हॉल टेक्स्ट बुक ऑफ मेडिकल फिजियोलॉजी, 4th साउथ एशिया एडिशन बाय जॉन ई हॉल एंड माइकल ई हॉल। सो होम्योस्टेसिस मतलब मेंटेनेंस ऑफ नियर कंस्टेंट कंडीशन इन द इंटरनल एनवायरनमेंट, जो कि आपका एक्स्ट्रा सेलुलर फ्लूइड होता है। मेंटेनेंस ऑफ नियर कंस्टेंट कंडीशन इन द इंटरनल एनवायरनमेंट। आपका इंटरनल एनवायरनमेंट कौन है? एक्स्ट्रा सेलुलर फ्लूइड है। ठीक है। नेगेटिव फीडबैक मैकेनिज्म, feedback that reduces, hence known as negative feedback, the output of a given system. For example, high circulating level of a hormone reduces the further secretion of that hormone. Positive feedback, feedback that increases, hence positive, the output of a given system. For example, injury resulting in bleeding result in release of a clotting factor that themselves increase the clotting processes. Physiology is the science that seeks to explain the physical and chemical mechanism that are responsible for the origin, development, and progression of life. Each type of life, from the simplest virus to the largest tree or complicated human beings, has its own functional characteristic. Therefore, the vast field of physiology can be divided into viral physiology, bacterial physiology, cellular physiology, plant physiology, vertebrate physiology, mammalian physiology, human physiology, and many more subdivisions. Human physiology. The science of human physiology attempt to explain the specific characteristic and mechanism of the human body that make it a living beings. The fact that we remain alive is the result of a complex control system. Hunger makes us seek food, and fear makes us seek refuge. Sensation of a cold makes us look for warmth. Other forces causes us to seek fellowship and to reproduce. The fact that we are sensing, feeling, and knowledgeable being is part of this automatic sequence of life. These special attributes allow us to exist under widely varying conditions which otherwise would make life impossible. Cells are the living unit of the body. The basic living unit of the body is the cell. Each organ is an aggregate of many different cells held together by intercellular supporting structure. Each type of cell is specially adapted to perform one or a few particular function. For instance, red blood cell, numbering about 25 trillion in each human beings, transport oxygen from the lungs to the tissue. Although red blood cells are the most abundant of any single type of cell in the body, about 75 trillion additional cells of other types perform function different from those of the red blood cell. The entire body then contains about 100 trillion cells. Although the many cells of the body often differ markedly from one another, all of them have certain basic characteristics that are alike. For instance, oxygen reacts with carbohydrate, fat, and protein to release the energy required for all the cell to function. Further, general chemical mechanism for changing nutrients into energy are basically the same in all cells, and all cells deliver products of their chemical reaction into the surrounding fluid. Almost all cells also have the ability to reproduce additional cell of their own kind. Fortunately, when cells of a particular type are destroyed, the remaining cell of this type usually generate new cell until the supply is replenished. Extracellular fluid, the internal environment. About 60% of adult human body is fluid, mainly a water solution of iron and other substances. Although most of this fluid is inside the cell and is called as intracellular fluid, about one third is in the space outside the cell and is called extracellular fluid. The extracellular fluid is in constant motion throughout the body. It is transported rapidly in the circulating blood and then mixed between the blood and the tissue fluids by diffusion through the capillary walls. In the extracellular fluid are the iron and nutrients needed by the cells to maintain life. Thus, all cells live in essentially the same environment. The extracellular fluid, for this reason, extracellular fluid is also called the internal environment of the body or milieu interior, a term introduced more than 150 years ago by the great 19th century French physiologist Claude Bernard. Cells are capable of living and performing their special function as long as the proper concentration of oxygen, glucose, different iron, amino acid, fatty substances, and other constituents are available in this internal environment. Now, difference between extracellular and intracellular fluid. The extracellular fluid contain large amount of sodium chloride and bicarbonate ion plus nutrient for the cell such as oxygen, glucose, fatty acid, amino acid. It also contain carbon dioxide that is being transported from the cell to the lungs to be excreted, plus other cellular waste product that are being transported to the kidney for excretion. The intracellular fluid differs significantly from the extracellular fluid. For example, it contains large amount of potassium, magnesium, and phosphate ion. Potassium, magnesium, and phosphate ion instead of the sodium and chloride ion found in the extracellular fluid. These differences are highlighted in figure 5.2. Special mechanism for transporting ion through the cell membrane maintain the ion concentration. Difference between the extracellular and intracellular fluid. These transport processes are discussed in chapter number 4. Homeostasis, maintenance of a nearly constant internal environment. Homeostasis. In 1929, the American physiologist Walter Cannon coined the term homeostasis to describe maintenance of a nearly constant condition in the internal environment, that is the extracellular fluid. Walter Cannon. नहीं. अच्छा. Essentially, all organ and tissue of the body perform function that helps maintain this relatively constant condition. For instance, the lungs provide oxygen to the extracellular fluid to replenish the oxygen used by the cell. The kidneys maintain constant ion concentration, and the gastrointestinal system provides nutrients. A large segment of this text is concerned with how each organ or tissue contribute to homeostasis. Normal body function require the integrated action of cell, tissue, organ, and multiple nervous, hormonal, and local control system that together contribute to homeostasis and good health. Disease is often considered to be a state of a disrupted homeostasis. However, even in the presence of a disease, homeostatic mechanisms continue to operate and maintain vital function through multiple compensation. The discipline of pathophysiology seeks to explain how the various physiological processes are altered in disease or injury. This chapter outlines the different functional systems of the body and their contribution to the homeostasis. We then briefly discuss the basic theory of the body's control system that allows the functional system to operate in support of one another. Extracellular fluid transport and mixing system, the blood circulatory system. Extracellular fluid transport and mixing system, the blood circulatory system. Extracellular fluid is transported through the body in two stages. The first stage is a movement of a blood through the body in the blood vessel, and the second is movement of a fluid between the blood capillaries and the intercellular spaces between the tissue cell. Figure 1.1 shows the overall circulation of the blood. All the blood in the circulation traverses the entire circulatory circuit an average of once each minute when the body is at rest, and as many as 6 times each minute when a person is extremely active. As blood passes through the blood capillaries, continual exchange of extracellular fluid also occurs between the plasma portion of the blood and the interstitial fluid that fills the intercellular spaces. This process is shown in figure 1.2. The walls of the capillaries are permeable to most molecules in the plasma of the blood, with the exception of a plasma protein, which are too large to readily pass through the capillaries. Therefore, large amount of a fluid and its dissolved constituent diffuse back and forth between the blood and the tissue spaces. As shown by the arrows, this process of diffusion is caused by kinetic motion of the molecule in both the plasma and the interstitial fluid. That is, the fluid and the dissolved molecule are continually moving and bouncing in all directions within the plasma and the fluid in the intercellular spaces as well as through the capillary pores. Few cells are located more than 50 micrometer from a capillary, which ensures diffusion of almost any substances from the capillary to the cell within a few seconds. Thus, extracellular fluid everywhere in the body, both that of the plasma and that of the interstitial fluid, is continually being mixed, thereby maintaining homogeneity of the extracellular fluid throughout the body. Now, regulation of a body function. Nervous system. The nervous system is composed of three major parts: the sensory input portion, the central nervous system जो कि इंटीग्रेटिव पोर्शन होता है, एंड द मोटर आउटपुट पोर्शन. Sensory receptor detects the state of the body or state of the surrounding. For instance, receptor in the skin alert us whenever an object touches the skin at any point. The eyes are sensory organ that gives us a visual image of the surrounding area. The ears are also a sensory organ. The central nervous system is composed of a brain and spinal cord. The brain can store information, generate thoughts, create ambition, and determine reaction that the body perform in response to the sensation. Appropriate signal are then transmitted through the motor output portion of the nervous system to carry out one's desire. An important segment of the nervous system is called autonomic system. It operates at a subconscious level and the controls many functions of the internal organ, including the level of pumping activity by the heart, movement of the gastrointestinal tract, and secretion by many of the body's gland. Hormone system located in the body located in the body are eight major endocrine glands and several organ and tissue that secrete chemical substances called as hormone. Hormone are transported in the extracellular fluid to other part of the body to help regulate cellular function. For instance, thyroid hormone increases the rate of most chemical reaction in all cell, thus helping to set the tempo of a bodily activity. Insulin control glucose metabolism. Adrenocortical hormone controls sodium and potassium ion, protein and protein metabolism. Parathyroid hormone control bone calcium and phosphate. Thus, hormone provide a system for regulation that complements the nervous system. The nervous system regulate many muscular and secretory activities of the body, whereas the hormonal system regulate many metabolic function. Historical dignity. Ancient Egyptians appear to have had a fair idea of the human anatomy based on their process of embalming and mummification. The structure and function of the human body were unclear to the ancient Greek. Galen derived his understanding of the anatomy of the human body from the dissection of animals and from examining the wound of the gladiator to whom he was a physician. Aristotle and Hippocrates attempted to infer function from a philosophical point of view. All this changed with the dissection of human body, starting with Vesalius and continued by others. The first major breakthrough in Western medicine with regard to the function of the body was perhaps the publication by William Harvey in 1628 of the circulation of the blood, protection of the body. ଆଉ ରହିଲା ଜାଣିକିରି ଦି ପେଜ protection of the body. Immunosystem. The immunosystem consists of a white blood cell, tissue cell derived from white blood cell, the thymus, lymph node, and lymph vessel that protects the body from the pathogens such as bacteria, viruses, parasites, and fungi. The immune system provides a mechanism for the body to distinguish its own cell from the foreign cell and substances. दूसरा, destroy the invader by phagocytosis or by producing sensitized lymphocyte or specialized protein. Example हो गया antibodies that either destroy or neutralize the invader. दूसरा, integumentary system. The skin and its various appendages, including the hair, nails, glands, and other structure, covers, cushion, and protect the deeper tissue and organ of the body, and generally provide a boundary between the body's internal environment and the outside of the world. The integumentary system is also important for temperature regulation and excretion of the waste, and it provides a sensory interface between the body and external environment. The skin generally comprises about 12 से लेकर के 15% of body weights. Reproduction. Sometimes reproduction is not considered as a homeostatic function. It does, however, help maintain homeostasis by generating new beings to take place of those that are dying. This may sounds like a permissive usage of the term homeostasis, but it illustrates that in the final analysis, essentially all body structure are organized such that they help maintain the automaticity and the continuity of life. Control system of the body. Control system of the body. The human body has thousands of control systems. Some of most intricate of these systems are genetic control system that operate in all cells to help control intracellular and extracellular function. This subject is discussed in chapter number 3. Many other control systems operate within the organ to control function of the individual part of the organ. Other operate throughout the entire body to control the interrelations between the organ. For instance, the respiratory system operating in association with the nervous systems regulates the concentration of carbon dioxide in the extracellular fluid. The liver and pancreas regulate the concentration of glucose. Liver and pancreas regulate the concentration of glucose in the extracellular fluid, and the kidney regulate concentration of hydrogen, sodium, potassium, phosphate, and other ion in the extracellular fluid. Now, normal ranges as a physical characteristic of important extracellular fluid constituent. Table 1.1 lists some important constituent and physical characteristics of the extracellular fluid. along with their normal value, normal ranges, maximum limit without causing death. Huh? Normal ranges, maximum limits without causing death. Notes the narrowness of the normal range for note the narrowness of the normal range for each one. Values outside this range are often caused by illness, injury, or major environmental challenges. Most important are the limit beyond which abnormalities can cause death. For example, an increase in the body temperature of only 11 degree Fahrenheit or 7 degree Celsius above normal can lead to a vicious cycle of increasing cellular metabolism that destroy the cell. Note also narrow range for acid base balance in the body with a normal pH value of 7.4 and the lethal value only about 0.5 on either side of the normal. Another important factor is the potassium ion concentration, because whenever it decreases to less than one third of the normal, a person is likely to be paralyzed as a result of the inability of a nerve to carry signal. Alternatively, if potassium ion concentration increases to two or more times of the normal, टू और मोर टाइम्स, दो गुना होगा या फिर मोर टाइम, दो से ज़्यादा या फिर टू और मोर टाइम्स increases टू or more times the normal, the heart muscle is likely to severely depressed. Also, when calcium ion concentration falls below one half of the normal, a person is likely to experience titanic contraction, titanic contraction of the muscle throughout the body because of the spontaneous generation of excess nerve impulse in the peripheral nerve. When glucose concentration falls below one half of the normal, a person frequently exhibit extreme mental irritability and sometimes even has convulsion. These examples should give one an appreciation for the extreme value and even necessity of the vast number of the control systems that keep the body operating in health. In the absence of any one of these control, serious body malfunction or death can result. The discussion of homeostasis forces us to ask whether this poses limits on human endurance. History is filled with examples of people who have endured and survived extreme impact on their bodies. For instance, soldier suffered extreme hypothermia during the retreat of Napoleon's army from Russia in 1812, and some survivor of the Titanic, which hit an iceberg and sank in 1912, spent hours in icy water before they were rescued. In 1999, Swedish skier called Anna Bogenholm, who was trapped under ice in water ice in water for 80 minutes, has a recorded core body temperature of 13.7 degrees Celsius, While most of us lose about 2 liters of fluid from our bodies per day, which we replace largely through drinking fluids or eating foods. Soccer player can lose up to 6 liters of fluid in a 90-minute game. We are also constantly exploring our physiological limits in sports. The current marathon of 42.195 km derives its name from the legend of Philippides, who, after taking part in the Battle of Marathon between the Persian and Greeks, ran the whole distance to Athens to carry the news of victory, only to collapse and die. Today, the endurance of athletes take part in even longer races called ultramarathon, which are now being extensively studied in terms of their physiological consequences. Characteristic of a control system. The aforementioned example of a homeostatic control mechanism are only a few of many thousands in the body, all of which have certain characteristics in common as explained in this section. Negative feedback. Most control system of the body act by negative feedback, which can best be explained by reviewing some of the homeostatic control system mentioned previously. This is because the purpose of a negative feedback is to ensure homeostasis in the regulation of carbon dioxide concentration. A high concentration of carbon dioxide in the extracellular fluid increases pulmonary ventilation. This in turn decreases the extracellular fluid carbon dioxide concentration because lungs expire greater amount of carbon dioxide from the body. In other words, the high concentration of carbon dioxide initiate event that decreases the concentration towards normal, which is negative to the initiating stimulus. Conversely, a carbon dioxide concentration that falls too low result in feedback to increase the concentration. This response is also negative to the initiating stimulus. In the arterial pressure regulating mechanism, a high pressure causes a series of reactions that promotes a lowered pressure, or a low pressure causes a series of reactions that promotes an elevated pressure. In both instances, these effects are negative with respect to the initiating stimulus. Therefore, in general, if some factor become excessive or deficient, a control system initiates negative feedback, which consists of a series of changes that return the factor towards a certain mean value, thus maintaining homeostasis. Now, gain of a control system. उसे पढ़ने से पहले इंपॉर्टेंट कॉन्स्टिट्यूएंट एंड फिजिकल कैरेक्टरिस्टिक ऑफ एक्स्ट्रासेलुलर फ्लूइड. सो कॉन्स्टिट्यूएंट में आपका आ जाएगा ऑक्सीजन, वेनस ऑक्सीजन, जिसका नॉर्मल वैल्यू है 40. नॉर्मल रेंज आ जाएगा 35 से लेकर के 45. यूनिट हो जाएगा mm/Hg. कार्बन डाइऑक्साइड वेनस वाला नॉर्मल वैल्यू 45, नॉर्मल रेंज आएगा 35-45. सोडियम आयन नॉर्मल वैल्यू हो गया 142, नॉर्मल रेंज हो गया 138 से लेकर के 146. तो इसका यूनिट हो गया मिली मोल्स पर लीटर. आयन का यूनिट क्या है? मिली मोल्स पर लीटर. ठीक है. उसी तरीके से पोटासियम आयन सबसे बड़ा इंपॉर्टेंट है. 4.2 हो गया इसका नॉर्मल वैल्यू. एंड इसका नॉर्मल, एक होता है नॉर्मल वैल्यू, एक होता है नॉर्मल रेंज. नॉर्मल वैल्यू हटा दो, उसके जगह पर रेंज लगा दो. ठीक है. सो पोटासियम आयन का नॉर्मल वैल्यू हो जाएगा 4.2, बट रेंज की अगर हम बात करेंगे तो ये 3.8 से लेकर के 5.0, इसका कंसेंट्रेशन भी वही सेम है। आयन को मापने के लिए यूनिट मिलीमोल्स पर लीटर, सीधा कहानी खत्म। कैल्शियम आयन का नॉर्मल वैल्यू हो जाएगा 1.2, इसका नॉर्मल रेंज है 1.0 से लेकर के 1.4 मिलीमोल पर लीटर, सबको पता है। क्लोराइड आयन 106 होची नॉर्मल वैल्यू, बट रेंज ହେଇଗଲା 103 ରୁ ନେଇକରି 112 पर्यंत मिलीमोल पर लीटर, सबको पता है। बाई कार्बोनेट आयन जो कि होता है 24, नॉर्मल वैल्यू 24, बट नॉर्मल रेंज हो गया 24 से लेकर के 32 एंड मिलीमोल पर लीटर, सबको पता है। ग्लूकोज नॉर्मल वैल्यू हो जाएगा 90, नॉर्मल रेंज हो गया 75 से लेकर के 95, बट यहाँ पर आपका यूनिट आ जाएगा मिलीग्राम पर डेसीलीटर। नाउ बॉडी टेम्परेचर 98.4 फारेनहाइट, बट सेल्सियस रे 37°.0 सेल्सियस। नॉर्मल रेंज हो गया 98 से लेकर के 98.8 फारेनहाइट, ठीक है। बट मतलब 37.0 डिग्री सेल्सियस, तो इसका यूनिट डिग्री फ़ारेनहाइट हो जाएगा, डिग्री सेल्सियस हो जाएगा, ठीक है। बट एसिड बेस हो जाएगा नॉर्मल वैल्यू 7.4, नॉर्मल रेंज आएगा 7.3 से लेकर के 7.5, एंड इसका यूनिट हो जाएगा आपका pH, ठीक है। नाउ गेन ऑफ ए कंट्रोल सिस्टम, द डिग्री ऑफ इफेक्टिवनेस with which a control system maintain constant condition is determined by the gain of a negative feedback. For instance, let us assume that a large volume of blood is transfused into a person whose baroreceptor pressure control system is not functioning, and the arterial pressure rises from the normal level of 100 mmHg up to 175 mmHg. Then let us assume that the same volume of blood is injected into the same person when the baroreceptor system is functioning, and this time the pressure increases only 25 mg. Thus feedback control system has caused a correction of कितना, a correction of 50 mg, जो कि डिडक्टेड होगा, दैट इज फ्रॉम 175 टू 25, ओके 50 माइनस होगा, ठीक है, ओनली 25 इंक्रीजेस 25, ओके। करेक्शन 25 बढ़ेगा, thus the feedback control system has caused a correction of 50 mmHg, that is from 175 to 125, 50 20 70 75, ठीक है, ओके 50 माइनस होगा तो ये आ जाएगा। देयर रिमेन्स एन इंक्रीज इन प्रेशर ऑफ 25 mg, ओके ठीक है, चलेगा। कॉल्ड द एरर व्हिच मीन्स दैट द कंट्रोल सिस्टम इज not 100% effective in preventing changes. हाँ जाऊँ। The gain of system is then calculated by using the following formula. So gain is equal to correction by error. गेन हो गया करेक्शन बाय एरर, तो 39 मिनट्स इसको ख़त्म भी नहीं कर पाया। और अगर देखूँगा 2 पेजेस 39 मिनट में हमारे लिए 2 पेजेस मतलब 4 पेजेस, ओके, आज के लिए इतना ही। फिर मिलते हैं किसी अगले एक बुक रीडिंग सेशन में। तब तक के लिए जय हिंद, वंदे मातरम। थैंक्स फॉर वॉचिंग।